Children, I have come up with another question on pulley block system. So here is the question, the situation where you have two blocks 4 kg and 1 kg which are connected to two different strings. So this is one string and this is the other string you can see here. So and the pulley, the bigger pulley, you can see both the pulleys are massless. The bigger pulley is being pulled up with force F is equal to 30 T Newton, which means it is variable and depends on time. So and the force is in Newton. G is supposed to be taken as 10. The velocity of 1 kg block when 4 kg block loses contact with the floor is dash. So that's our question. So here is the situation. So first we'll start solving this by assigning the tension in the string. So I am choosing this string. So let's say the tension in this string is T. You know, tension always tries to pull the mass. So this is the direction in which the tension is acting on 1 kg block. So if you go on with this entire string, the same string, so here also the tension becomes T, and if this is T and also this is T again, so that means this bigger pulley is being pulled with 30 T, which is equal to T plus T plus T. So I think I can write 3T is equal to 30 into small t. Here capital T is for tension and small t is for time. So the tension in the string changes according to time as 10T. So we can say that if F is equal to 30T is force on the pulley, then the tension in the string varies according to the relation capital T is equal to 10T. So let's draw the free body diagram. And if you observe, since 1 kg is lighter than 4 kg, when this pulley is pulled up with force at 30 T, 1 kg starts rising up first, and after a while 4 kg also rises up. So here when 4 kg block loses contact, the 1 kg would be in motion because it is started earlier. So we'll see what is the speed, the velocity of 1 kg block. So let's start doing that. Let's analyze when is 1 kg going to rise up. So here we can draw the free body diagram of 1 kg. So tension is T, but we can write in place of T as 10T. So I'm writing 10T here. And the gravitational force is 1G, which is G, actually G here. And if you observe here, since this is T and T, then you can write 2T here. So the tension which is trying to pull up the 4 kg block is 2T. Since capital T is 10T, which is 10 into small t, you can write this as 20T. So 20T is the force which is pulling up the 4 kg block. And also there is normal reaction here. So I can write normal reaction as N1 here, and here the normal reaction is N2, which is given by the ground. And this is 4G. Now if you observe, if you want the block to lose contact with the ground, then N1 has to be 0. So if you see, the net force on this 1 kg block is 10T plus N1 minus G, because G is acting downward. So we subtract it. It is like sigma Fy, adding all the forces along y direction. So 10T and N1 in upward direction, and G we can substitute as 10. This is the net force, and this is equal to MA. M is mass of this 1 kg. So I think I can write 1A. So 1 into A. So acceleration of 1 kg block. So the acceleration of 1 kg block is actually 10T plus N1 minus 10. But what you have to realize here is, when you want this block to rise up, see, when you substitute T is equal to 0, then N1 is non-zero. The still block still has no acceleration. I mean, the block rises up only if 10T is greater than G, which means N1 becomes 0 when T is greater than 1 second. Because when you substitute T as 1, is 10 and 10, so it balances, and then the blocks start rising up. So our condition is N1 is 0, it loses contact with the ground when T is greater than 1 second. Now let's try to analyze the same thing here. So if the 4 kg block has to rise up, then the gravitational force on it is 4g and the applied force is 20t. So 20t must be greater than 4g, which is 40. So t must be greater than 2 seconds. So what you have to understand here is, for t greater than 1 second, 1 kg block starts rising up, and for t greater than 2 seconds, 2 kg block, 4 kg block start rising up. In a duration of 1 second to 2 second, like t is equal to 1 second to 2 second, only 1 kg block will be in motion, whereas 4 kg blocks will still be at rest. So now our question is to find out the velocity of 1 kg block when 4 kg block loses contact with the floor. So when does 4 kg block lose the contact with the force at t equal to 2 seconds? And the motion of 1 kg starts at t equal to 1 second. So we're supposed to find out the speed gained by 1 kg from 1 second to 2 seconds. Since the force on 1 kg is variable, I can write the net force as 10t minus 10 is equal to ma, which is 1a, and the value of normal has become 0. You can observe that here. Since the force is variable, acceleration is also variable. I need to use dv by dt, which is acceleration, is equal to 10t minus 10. So let's try solve this one. So you have dv is equal to 10t minus 10 times dt. So let's integrate this with proper limits. So integration of dv and integration of this one, and the limits are of t is from 1 second to 2 seconds, because at t equal to 0 to 1 there is no motion of 1 kg at all, and initially when t is 1 the block is at rest, and let's say the velocity of the block 1 kg is v after at the end of 2 seconds. So integration of dv is v and the limits are from 0 to v, and the integration of 10t is 10t square upon 2 minus integration of simply 10 is 10t, and the limits are from 1 to 2. So let's continue doing this. So you substitute upper limit, then you have v minus 0 is equal to, here we'll substitute the upper limit first, then it is 10 into 2 square upon 2 minus 10 into 2 is 20. This is the upper limit, minus when you substitute the lower limit is 1 square into 10 is 10 by 2, which is 5 minus 10. So this will give you 20 minus 20, this is 0, and minus 5 minus 10 is minus 5. So the answer becomes 5 meter per second. So the speed or velocity of 1 kg block when it loses contact with the, when 4 kg loses contact with the ground is, the answer for this question is 5 meter per second. Oh yeah, the unit is already mentioned, so the answer is just 5 meter per second. That's the answer for this question.